First is going to be TLC, or thin layer chromatography. In thin layer chromatography, or any chromatography in general, separation is a separation technique. The advantage of chromatography is that you use very small sample size. So if you just have a drop of a compound, you can't do distillation or recrystallization with one drop of a sample, especially if it's like a stain, and then you have to purify it. So you get less than one drop. The best way for that, the best separation technique for that type of sample size is going to be chromatography. For when you do chromatography separation by chromatography technique, separation is based on difference in polarity of the molecules. So for recrystallization, the difference was in solubility of that sample in solvent. For distillation, separation was based on difference boiling point. So you had difference in boiling points of the compound. With the lower boiling point, it would be eluted first, or it would vaporize first, and then for compound with higher boiling point would change to vapor at the higher temperature or later, and that time difference and temperature difference allowed you to do separation. For extraction, it was the acid-base property of the compound. You had one compound that was acidic, one was neutral, or if it's one basic, one acidic. So the acid-base nature of the component of the mixture must be different if you want to use extraction or acid-base extraction. When it comes to the chromatography, is going to be based on difference in polarity. So your TLC plate, you are going to design a TLC plate. You draw a line using a pencil. You should not use pen. You are going to mark your spots. You can do 4 in 1, and if you cannot fit 4 in 1, you can choose like 2 plates and do let's say 3 and then another 2. You can do that also. So you are going to mark your spots, then you're going to place your sample using a capillary tube, making sure that you're not touching the surface. You're not going to break the surface of the plate. Your TLC plate has a shiny side. Let me bring a sample. Has a shiny side and it has a dull side. When you use the TLC plate, you should never touch the dull side, because the oil from your hand, it can get on it and it will cause contamination to your chemical later. You should hold on the side only. The shiny side is okay. You can touch the shiny side because there's no action or separation is taking place on that side. So you draw a line with the pencil about half an inch from the bottom of this plate, and the coating on this plate is it could be a polar or non-polar sample. The ones that we are using today, they have a polar. We have a polar coating here on the plate. So with the polar coating, we have 3 known sample, and we are working with one unknown. It has to be like side-by-side comparison. So your unknown, it must be placed on the same plate that you have your known sample. So if this is compound 1, this is your compound 2, and this is your compound 3. So you would add a drop using a capillary tube without touching it or without injury, without breaking the plate. You add a drop of compound 1, 2, and 3, and in one of them, it doesn't have to be it doesn't have to be the second one. It could be any of them. You place your unknown. So your unknown, it goes to one of spots, and then the other three would take your three known sample. Your unknown is going to be one of the three known compound because it has to be a side-by-side comparison for the TLC. Then you are going to place this in developing chamber. What goes into developing chamber? The developing chamber is going to be your solvent that is going to elute this or is going to separate it. The level of the solvent, okay, the level of the solvent cannot be higher than your sample, because if you fill up your bottle up to this level, it's going to wash everything down and it will go mixed with the solvent. Then instead of having like a separate spots, you're going to have like one line or everything mixed. You don't want to mix them, you don't want to wash them, you don't want to dissolve in the solvent. So what's going to happen after you place that in the developing chamber, based on the capillary action, the solvent is going to move up in the move up on the plate. So the solvent is going to move up slowly, and you leave this in the solvent, developing solvent, and you don't watch it, it can actually go to the top and it can go down from the other side. It continuously is going to go up by the capillary action. So as the solvent reaches to this sample, now your sample then has two choices: to be friend with the solvent and move up, or to be friend with the stationary phase and stay there. So it depends on the attraction or interaction between your sample with the stationary phase, which is this polar powder or coating we have, and the solvent. If your sample is polar and the stationary phase is polar, is going to interact more with the stationary phase. It likes that stationary phase. It wants to stay with the stationary phase, and it's going to move up slowly because there is a force that is moving, pushing these up. But if the sample likes the stationary phase, it's going to move very slow. Now, if your sample is non-polar and the stationary phase is polar, there is really no interaction, no interest of that sample to the stationary phase, and it wants to move up, especially the solvent that you have. It is non-polar, so it's the same nature as your sample. As the solvent moves up, the sample is going to also move up, and you have to pick proper solvent in order to move up the sample with it, but it doesn't, your sample should not move as fast as the solvent. So when you are done, like when the solvent reaches to the top, almost up, like half an inch from the top of the plate, you take it out and you mark that line. And this line, the distance between the line that you have your sample and the solvent front, that would be the distance traveled by solvent. When you are done with developing this, you are going to take it out, dry it, look at it under the UV lamp. And when you look at under UV lamp, you should be able to see these spots now moving up. Let's say if your sample moves up like this, what does it mean if you can see? Can you tell me what does this mean? Your unknown would be which compound? Your unknown has traveled same distance as your compound 1. So your unknown is going to be your unknown, your compound 1. So these two is going to be the same. So you calculate, you find the distance traveled by the sample, and you compare to distance traveled by solvent, you find a ratio, and that is called a RF value or ratio factor. So for this compound, if this is A for compound 1, is going to be A, and this is the solvent front or the distance traveled by the solvent. If I call it like a DS, it's going to be DS. And you will find a value for compound 1. You will find the value for unknown, RF value for unknown, and if this is going to be U for the unknown traveled, how much is going to travel? U divided by the distance traveled by the solvent, and you find this value. If these two values match, the RF value for your compound is the same as RF value for one of your known sample, then these two compounds must be the same. Take a screenshot of this board now, and that would be your first screenshot to be submitted with your report. Take a screenshot, please, your first screenshot. Now, if you cannot fit all 4 of them, then in one plate, you could separate it. It would be your compound 1, compound 2, and your unknown. And then compound 3 with your unknown. Your unknown must be on the same plate as your known compound. So if your unknown travels as your compound 2 travels, then your unknown, it does match based on the identity with the unknown 2. If it moves up with same as unknown 1, then it would match with the identity of the unknown 1 with your known sample 1. So your unknown is going to be, in this case, it would be similar to the known sample 1. Any questions about the chromatography? Any questions, the basic for chromatography? Any questions about calculating the ratio factor or RF, or how to identify unknown using the values for RF, or looking at the spots after you develop the plate, the TLC plate after your reaction? No question? No? If the RF is the same, then they have the same identity. Yes, exactly. Very good. If the RF value for your unknown is same as one of the known sample, then the identity is the same because you were treating both under similar condition. So it would go at the same distance, would be traveled by the unknown and the identical compound. They would be the same. Any questions here? If there is no question, I'm going to have to move and actually perform the experiment with the, this is for TLC, and then we are going to set up also column chromatography. With the column chromatography, you have a stand, you have your clamp or the burette clamp that you are going to use to hold the column, and then you are going to prepare the column. There is a procedure how to prepare the column. So you are going to use the cotton ball, then you use sand or a glass wool, or use the sand again, and then you fill up this with the stationary phase, which again is like alumina. Alumina is polar. Then you bring your sample, the mixture of the two samples that you have, you prepare based on following the procedure which we are going to prepare, and use solvent constantly to elute this. So if this is polar, your compound A and B in the mixture, if A is polar, B is non-polar. Which one would move faster? A or B? Which one would come out first? Your stationary phase is going to be polar. If this is polar, okay, if the stationary phase is polar, polar wants to interact with the polar stationary phase. So if it's polar and polar is going to attach to the stationary phase, it's not going to go down with the mobile phase. So the mobile phase is going to move, the non-polar is going to actually move with the solvent faster. If this is polar and your compound is polar, it would spend more time. Then you have to actually pull it stronger. How could you pull it stronger? You have to bring a polar solvent. So if your compound is polar, when you bring in polar solvent, it's going to wash the polar solvent and bring the polar solvent. So if your solvent first is non-polar, it's going to bring the non-polar down first, and then to bring the polar, you have to use a more polar solvent to wash out or to elute, that's the proper term for it, to elute the polar compound and bring it out. That's why in column chromatography, we are using 3 different solvents for elution. So eluting solvent first is non-polar or less polar, and then we go to more polar and most polar solvent to make sure that the polar sample also is being eluted. Okay, going to start the you could take this again as a second screenshot. So you have 2 screenshots now. I expect one of these 2 screenshots to be in your ear folder. Okay. Moving to the actual experiment. So I'm taking a plate and place using a pencil. I'm going to draw, like very lightly, I'm going to draw on the plate a line that the sample line. I'm going to spot it like very lightly. Bring my lab manual. In the lab manual, I'm going to sketch what is going to each one. So based on the procedure that I'm performing, I'm going to write, because I don't have space here to write what goes in each of the spots, but I have to have a sketch of it so I know what goes on the spot 1, 2, and 4. So later on, I lose track of which one actually was the first spot from the left to right. I have to have a label for it. Right. Question, why did I change it? I have to show you here. This corner was chipped off, and because it was chipped off, I'm not using this, and I made a new plate for that one. Okay. So with the developing sample chamber, going to use the mixture that is prepared for me already in the fume hood. I'm going to get 5 milliliters of this mixture, that is the 84:1. That is the ratio of which is a mixture of the methylene chloride, methanol, and acetic acid. I have mixture of the solvent. That's to adjust the polarity. And I'm going to use a piece of filter paper. This piece of filter paper that is used here, going to place it inside the developing chamber. The purpose of using this paper is not for chromatography, because you've done paper chromatography for biology lab most likely. But for me, if I have the solution here, the paper is going to pull up the solution and evaporate from surface of the plate, and it's going to saturate the developing chamber faster than I do have space with the vapor of the solvent. The benefit of that is when I'm placing my actual plate in, the solvent is going to move with a straight line. If it's not saturated, it can move up the curve, and if it does move up with the curve, then calculation for RF is not going to be accurate, because the distance traveled by solvent is not going to be the same for all 4 samples. Does it make sense? The other thing I should avoid is, after I have my plate inside the developing chamber, I cannot lift it up and look at it, because when I lift up and look at it, I'm going to create wave in the liquid, in the solution that I have. And as I create waves here, then this is going to move also with waves. And if it moves up, not a straight line, and it moves up with the wave, if I create the wave by moving this developing chamber often, then the distance traveled for all sample is not going to be the same. So the fractions for RF values that I'm calculating is not going to be accurate. So this is my practice. This is the one with the chipped off. So I'm not using this. I'm just showing what could happen. So I'm going to prepare my developing chamber, close the cap first, leave it for the inside of the chamber to be saturated with the vapor. So I would have like smooth travel of the solvent up. I'll be right back. I'm getting the sample from you with the developing solvent. I have the 5 milliliter. This 5 milliliter is not a magic number. It's just an approximate number that, based on the equipment I had in the lab, I chose the 5 milliliter for when I was writing the procedure for this experiment in the lab manual, because with the 5 milliliter, I make sure that the level of the liquid is not higher than the level of the sample that I have in my plate. So if you have like wider container, or like more like a smaller container, the 5 milliliter may not be the right number, but we want to make sure the solvent, it covers the bottom of the jar, but at the same time is going to be lower than this level of sample. So I'm going to spot the samples. So with the spotting of sample, take you with your here where I have my samples. I get unknown also. So the first one is going to be aspirin. So I put one spot of aspirin on the left side. Okay, I cannot use this anymore because I cannot mix with anything, any other solution. A new capillary tube for 2 is going to be acetaminophen. 2 is going to be acetaminophen, so I put a spot for 2. Three is caffeine. And 4 is going to be unknown. And 4 is unknown. So I have my samples spotted already. I place in the developing chamber, open the container, open the jar, and place it in. Okay, it doesn't fit and I don't want to break it. Okay. Okay. I'm going to have to cut the side because it doesn't fit into the jar and I don't want to bend it, because if I bend it, the solvent is not going to move up straight. Okay, it's going to stay in. Do you see the moving of the solvent? Yes, okay. So the solvent is moving up, and when it reaches to about ½ an inch from the top, I have to stop and I have to mark it with the pencil again for the solvents. I have to be careful with that, not to pass, not to go over the top. Okay. As I'm waiting, I have to monitor my setup to make sure that it doesn't go over the top. And I am going to prepare the column or get the stuff ready to prepare the column. Take a small piece of glass wool and place it in the, doesn't have to be even that big. We place it in the inside the column. See if this one works to push it down. Okay. With that copper wire, it was actually pulling up every time I was trying to push it down. I had to bring a steering rod to push it down. While we are monitoring the jar to make sure that it doesn't go past the top, I can work on the preparation of the column for column chromatography. And our next item after the glass wool is to add sand. Do you know what's the purpose of using sand? What's the purpose of using sand here? Is to level off the glass wool, because you want to make sure that so even distribution, yes, to level off the glass wool. Two, we cannot see because the lighting is too. Is that for the setup here that you can't see the setup? Okay. I will check it for you. It might be hard for you to see it. I'm going to bring the camera close so at least you could see the ones that the shade is different, where the wet paper is versus the wet plate is versus dry part is in top. And then I will stop it when it reaches to the half an inch from the top of the plate. So I'm going to use hexane based on the step 2 of the preparation of column on page 68 of your lab manual. Going to bring some hexane for that. I'm going to label my beaker with the hexane because all of these chemicals or solvents that we have, they have same color. I don't want to get mixed up. I fill up 2/3 of the column with hexane. So I have my hexane monitoring this at the same time. Then we add our absorbent, which is aluminum. Okay, before causing any trouble to myself or you, I'm going to take out the plate. Right away, I have to mark it, otherwise when it gets dry, I can't see. So I have the line that solvent has moved up. I wait until it's dry, then we take it to the UV lamp. I need to add more of the aluminum. About 6 inches in height at least. So I'm going to stop right there. So this should be enough of aluminum. Last part, adding sand. Making sure this is okay. The column is ready. This is just preparing column. We are going to take this to the UV lamp and try to visualize it under the UV lamp to try to see the, where is the UV lamp? Our lab tech didn't put it out. Or, okay, the UV lamp is coming, is not out yet, is coming. So while we are waiting for the UV lamp, I can probably ask you to tell me what is my next step for the column chromatography. We're going kind of back and forth, but we are doing two experiments at the same time. I'm trying to use the time wisely and be more efficient. So what would be my next step for column chromatography after I prepared the column already? It's usually in that corner and we plug in. What's my next step? 0.2 grams of fluorine mixture. Okay. I get the 0.2 grams of fluorine mixture. So I add enough to make it 0.2 grams.
It's working. Well, it's not on. I turned it off, but it's working.
Thank you. Thank you. Okay. 0.2 grams. Exactly 0.2 gram is measured. And then we are going to dissolve in toluene. And I think now that the UV lamp is ready, let's finish up with the TLC and then we stay only with the column chromatography because it requires a lot of attention. You have to be constantly working and often. Two people is needed, but I try to do it as my best to perform the experiment by myself because we cannot never dry this sample, and I explain later. But let me finish with the TLC first. So I'm going to take the TLC plate, place it under UV lamp. Okay. And I won't see what you see on the camera. You gotta tell me if you can see and you take a screenshot of that. I'm just holding it so for you to take a screenshot. Did you take your screenshot? Perfect. What I'm going to have to do inside the UV, I have to take my pencil because when I take it out, it's not going to show the spots. See, when I take it out, I won't be able to see the spots. I have to leave it inside the UV. While it's inside the UV lamp, I'm taking my pencil and outlining the circles that shows each of the samples, and it shows the solvent line, which we got it already. Okay. I have the spots. Can you tell me my unknown is which compound based on what you see here? My unknown is going to be acetaminophen because the second mark here was acetaminophen and the unknown moved up at the same distance as the acetaminophen. Okay. And to calculate the RF value, you need numerical values that you would use here for your table to do the calculation, for your table as a table of data. And then you would need to, also use those RF values in your abstract and your conclusion. So the distance traveled by the solvent is going to be the distance traveled. I'm going to have to measure it. I don't know it, so just give me time. The distance is 7.20. So 7.20, that is for traveled by distance, by the solvent. The distance traveled by the solvent. For compound 1, is, I'm going from center to the line, and I will show you now. Compound 1 is known sample 1. Based on the chart, you know which one it is, right? Based on the chart we had for the first one was aspirin, and that number is 2.7, sorry, 2.6. 2.6. For compound 2 is 1.2. For compound 3 is 2.8. And for compound 4, $1.2. And these are all in centimeters. Okay. You can take a screenshot. And when you magnify it, you should be able to see the number because I wrote it down. Okay. And I'm going to take also a picture of it and send it to you. Let me bring my camera scanner. It takes time. Okay. It's not the best picture. Maybe picture is better for this one instead of the. I will try it later to see which one is better, picture or the scanning. Going to take a picture as well. Okay, picture is more clear. I will send you a picture later to D2L email. Okay. And you can include that picture into your lab report. And the screenshot you took from here, if it's good, you don't have to worry about that also. Okay. So if the screenshot that you took is good, you could just use as a picture for your calculation and for you have the numbers already. The numbers were 7.20, that's for centimeter for the solvent. For compound 1, which is aspirin, is a 2.6. Compound 2 is 1.2. Compound 3, 2.8. And compound 4 is 1.2, all in centimeters. And the drawing, you can draw a sketch in your lab notebook, but it's really, you don't have the plate, so you can use the picture. Okay, you can use the picture. Okay, we are going to move to next part, which is the column chromatography. Do you have questions about the TLC? Okay, that means no questions. That's okay. That's good. So I'm going to add the toluene to dissolve it and bring it back to start the experiment. Okay, I dissolve the sample or the mixture in toluene. And what's my next step? Please give the steps because I want you to tell me what to do. But I will repeat it what I'm doing after you tell me what to do next. What should I do next? What should I do next? Okay, it's dissolved already. Because it's dissolved, I finished that part already. It's dissolved. Next. Run the level of the liquid is talking about this liquid. Level of the liquid now is higher than the sand. So when you say run it below the sand, so I'm just going to open the stopcock here. So I'm opening the stopcock to bring the level of the liquid, which is the hexane, to the top of the sand. Okay? The top of the sand. And you can write the next step while I'm doing this, so I know what to do next. What's the next step? Is to, I was lucky it didn't spill, so I'll just, next step is to add the sample. Okay, I have my sample already. And I need to apply the solution, okay? Draw off to below the sand, perfect. Okay, now I have to start the elution process, and to elute, I'm adding solvent from the top of the sample, and I drain the solvent slowly. I'm eluting the solvent. What is happening first is my non-polar solvent. The non-polar solvent is going to dissolve and bring the solvent, as the solvent is coming down, it's going to bring the non-polar compound with it down. The non-polar compound that is here, it's colorless. When it's in the solution, it's colorless. So it's very hard for me to see it in the column. And because it's hard for me to see it, I'm going to have to basically test for it to see when it did reach to the bottom. To test it, I take a drop. I'm going to show you how it looks like when there is no chemicals. My compound 1 is not out. Fraction 1 is not out. When I dry it out, the glass is clear. See, it's clear. There is no white residue here. If my compound 1 reaches down, which is fluorine. Fluorine is the first compound. So I have a fluoronon and fluorine mixture. Fluorine is non-polar. It will come down with hexane, but very slowly it will come down. I have to test it with the watch glass to see if I'm getting pure hexane or is the hexane plus the fluorine. When it's just the hexane, after it's dry, it doesn't leave any white residue. When it's the hexane plus fluorine, you will see the residue. So I'm going to have to add solvent, drain, and test this. That's why I said this is like 2% job. I'm going to try my best to do this without getting the top of the sand dry. At any time, it should not be dry. So I'm going to have to do this very slowly. Open it to elute slowly, and I keep adding the solvent. And periodically, I have to test with the drop to make sure that drop is just hexane, no hexane with fluorine. And you know the difference, right? At this point, you should know the difference. If it's just hexane, it's going to be clear. If it's hexane plus fluorine, it's going to be white residue. It's clear, so it's just hexane. So I have to continue adding the hexane and continue testing for this. You see how often I have to test to make sure that I'm not going to miss when the hexane carries the fluorine. This is one of those experiments that it does appreciate two people working at the same time. But when you work in the research lab, you have to be able to do everything by yourself. You don't have assistant. So I'm kind of going back. I'm back to my graduate years when I was doing my either master's or PhD. So still is clear. Keep adding and testing. Testing, adding. If it's clear, I don't have to show you. As soon as I see the residue, then I will show you because you already looked and saw how it looks like if it's clear. There's really no white residue, that's all. That means it's clear. Okay, take a screenshot of the column chromatography setup. We're just adding the nonpolar solvent at this point. The solvent, the compound is already in the column when we applied the solution that I made with the toluene. It was a mix of the two compound and the toluene. So I'm just adding hexane as the nonpolar solvent now. You're welcome. So I'm adding and testing. Not yet. It does take time for it to come down. Okay. A white residue is forming now, but I don't know how I'm going to, what background is going to help you to see it. A black background for you. Do you see the white residue on the watch glass now? Yes? Okay. That is indication that my fraction 1 or the fluorine now is all the way down. And what's the next step for me to do? I cannot. This is my vase container. The beaker is the vase container. And I cannot elute the fluorine into vase container. I have to change it to fraction 1. I have to change this to collected in the flask 1, which is the fraction 1. Going to collected flask. And can you tell me for how long I should collect it in the glass into the fraction 1 container? For how long do I have to continue collecting it into fraction 1 container? Until all has been eluted. But how would I know? There is no color. How would I know that is all eluted? How would I know there is no more fluorine coming out with the hexane? So when I test it now, I see the white residue again on the glass. That means I still have the fluorine coming with the hexane. So I have a mixture, is a solution. So I have to continue this, elute and test, until I see no white residue. And when I see no white residue, that means all of the fluorine has been removed or collected, rather. So I'm going to test it again. Still, I have white residue. The top of column should never dry out. It should always contain some solvent, whatever solvent you're dealing with at that step. What's my next solvent? Because I have to think ahead and get my next solvent. What's my next solvent? When I switch from hexane, what should I switch it to? Hexane acetone mixture, because I'm trying to increase the polarity, right? Trying to increase the polarity of my solvent. Acetone has a CO double bond, and CO double bond makes the molecule to be more polar. Okay, still white residue. You have to be patient with these experiments. They are taking time, but it's okay as long as you don't leave the chemical that you want for fluorine left in the column. You collect it all. And this is the only way you can find out. By testing the drops, if it's white residue, that means you're collecting fluorine. Still present. Usually, like when it reaches mark 20, based on experiments that students did in the past, it's just like 20-25 milliliters of the hexane collected in flask. It's usually the time. But I don't trust that volume. I trust my white residue, formation of the residue, or no residue. So I have to test it. It's getting the, like, it's kind of very like tiny residue is forming, very tiny residue. So it's getting very close to it. And for the last one, no residue. No residue for the last one. So I can stop here and switch my solvent. So I'm going to stop here, just gonna add some so it doesn't dry before I go get the solvent for the next one. And I'll be right back. I have to get the solvent. Okay, what should I do next? Do I keep the fraction 1 flask here? No, switch it. So I have my fraction 1, go back to the waste container, and add the mixture of acetone to hexane acetone mixture. And can you tell me for how long I should add that? For 9:1 hexane acetone mixture, for how long should I add that? Until a yellow is noted. So the yellow color is visible. It's been visible since beginning of the elution or eluting, but it's not very distinct. That means you have like some sort of starts here and it comes down here, where it's more distinct, and it kind of levels off. So because this is polar, it's going to make this part move faster, and then you get like more specific line or more darker yellow color and more evened off layer. Okay, this part doesn't take long because we're just looking for a yellow band. And if I bring this closer, you see that we have that yellow band out here. So I can switch my solvent to acetone now. So I'm going from 9:1 to pure acetone, but it's not time for fraction 2 yet, because when should I collect the fraction 2? Can you tell me when should I collect the fraction 2? When the yellow band reaches the top of the plug. So when the yellow band reaches here, so all I want to collect here is the yellow band. The yellow band is going to be mixture of acetone and fluoronone, which is going to be yellow color. So I keep adding acetone until the yellow band reaches down here. As soon as I see the yellow color is going to go to waste, I switch it to the fraction 2 flask, and I collect in fraction 2 flask. But not yet, still is all the way up. You see the collections, right? When the yellow band still is here, and I'm waiting for it to reach down here. I keep adding more acetone. Any questions for the column chromatography while we are waiting? So we can use the time. Okay, no question. It could be very good news. Right? It could be good news that you don't have questions. That means the experiment is clear. You read the procedure and you have no questions. You just have to be careful with this top of the column. It should never get dry. And you notice at the beginning, I add the hexane first before adding the alumina, because I didn't want any cracks, any gap in the for the column. So if I put no liquid, or if I leave this area dry, when the alumina gets dry, it will crack, and then you have a gap. Then the separation is not going to be efficient. So the yellow color is all the way down here. Now I'm changing. You see the yellow color all the way down here. Now I'm switching the beaker into fraction 2, and I keep adding the same polar solvent. And how much of that solution should I collect? For how long should I continue collection or adding the acetone at this point? Could you tell me, please? I know when to stop collecting. Until all the yellow band has been removed. Perfect. When the yellow band entirely is eluted into fraction 2, I stop adding acetone. Then I have my fraction 1 collected already, which is my fluorine in one flask, and the fluoronone in the second flask. So chromatography as a separation technique is very strong. For identification technique, it's good, especially if you have like comparing known to unknown. So if you have your set of known samples, then is great. Like using fingerprint is perfect when you have a bank or database with the fingerprints of the people that you would suspect, right? If you don't have the data or the data set or the bank, then you get one single fingerprint is not going to help you to solve the problem. It's very similar idea here is you have to compare unknown to set of known samples. Okay, I think this is the last batch of solvent that I'm adding because it looks clear to me. Okay, I can stop now because the yellow color has been eluted completely. I can stop here. Next step is to take a screenshot, take a clear picture, try to make it as clear as possible for yourself. A screenshot of the fraction 1, fraction 2, and the vase container. Okay, take a screenshot. When you take the screenshot, then you use that as a picture in your lab report. And also one of the screenshots and the other file that you have for your picture, the screenshot files. The analysis for this, for me, is the qualitative analysis. I want to make sure that I have like a dark yellow color for the fluoronon. I want to make sure that no fluoronon went into the vase container, because if it did, it would be yellow color. So I didn't lose any fluoronon, and I did not collect too much of the sample, the solvent, because the yellow color still is strong. And the fraction 1, which is the fluorine, has no yellow color and decent volume. So I didn't start too late, or I just stop collecting too early. So that is the qualitative analysis of the second part of the experiment. So there's really data for second part of the experiment for your lab reports, but you will have you will have the pictures to include. So I'm going to take another picture and send it to you. Okay, questions for me? Questions from the chromatography, either column or the 10-layer chromatography? Or any questions from the pre-lab? Questions? Okay. Just need to call for attendance, and I'm going to stop recording, call for attendance, then work. To continue with your questions you might have. Do you have any questions about this experiment? Because if it's question about this experiment, that would be for the, I like to have it in the record. If it's concerned about something else, then it doesn't have to be for this experiment record. So the question is the qualitative analysis for the second part, yes. For the first part, you have data values, you have the distances, you have to create the table and do the calculation, show your calculation, because any calculation that you are performing, it has to be shown in the lab report for the first part. For the second part, we are not doing gas chromatography. We do have two gas chromatogram machine that we have in gas chromatography equipment that we have, or the instrument rather, that we have. The power that we need is a 220 for those, and what we have in that room is a 110 and has not been fixed yet, unfortunately. I wish that it gets fixed as soon as possible so we can use the two brand new equipment or the instruments that we have, but it doesn't work yet. Okay, any other questions? No? Okay, perfect. Let me stop the recording and